x equals x squared, g of x equals 5 minus x. 2 times f of x minus 2. So 2 of f of x minus 2 is this. Wherever I see x squared, I plug an x minus 2 in for it. So it's 2 times x minus 2 squared. That's all f of x minus 2 is. If f of x equals x squared, f of x minus 2 means wherever I see an x, I plug x minus 2 in for it. We square it, and then there's going to be a 2 on the outside because we're doubling whatever f of x minus 2 is. Minus 4 g of x. G of x they literally give you. It's 5 minus x. That's literally it. Now, at this point, we should know what is x minus 2 squared. We better know at this point, x minus 2 squared means I need to FOIL this out. So x minus 2 squared is that. And now we're distributing and combining like terms. 2x squared minus 8x plus 8 minus 20x. Oops, I'm sorry, minus 20. Stop making those mistakes. Minus 20 plus 4x. And then combine your like terms. 2x squared minus 4x minus 12. And that's going to be your answer. Is x plus 3 a factor? Well, we should know how to do this pretty well at this point. Drop the 1. We get negative 3. We get 2. We get negative 6. We get negative 24. We get a positive 72. So the answer is yes. The answer is yes. There we go. The other factor is x squared plus 2x minus 24. X plus 6, x minus 4, and we do need to bring the x plus 3 down as a factor. We are going to skip this problem for right now and go back to it at the end. We're going to come to this problem here first, okay? Where we need to recall how do we graph for a line, or how do we graph a line? 3y is less than or equal to 2x minus 9. We divide 3. We solve it for y. So you divide by 3, we get 2/3 x minus 3. It's a less than or equal, so it's a solid line. At this point, we all should be able to graph a line. Negative 3 is my y-intercept. Up to right 3, down to left 3. Down to left 3, we'll go up to right 3 one more time. My second line, 4x plus 3y is greater than 6. 3y is greater than negative 4x plus 6. We divide 3 on both sides. Y is greater than negative 4/3 x plus 2. So negative 4/3. 1, 2, 3, 4, left 3. 1, 2, 3, 4, left 3. 1, 2, down. 1, 2, 3, 4, left 3. 1, 2, 3, 4, down, or right 3. Down 4, right 3. This is going to be a dotted line. And now I need to do my shading. 0, 0. So 3 times 0 is 0, 2 times 0 is 0, 0 minus 9 is negative 9. Is 0 less than negative 9? It's not. If it makes a false statement, so 0, 0 makes this false. 0 is not less than 9. We shade away from the 0, 0. If I plug 0, 0 in here, is 0 greater than 6? Nope. So it's also false. I'm going to shade away from the 0, 0. So this right here is my answer. Plug 10, 0 in. That's an extreme point to check your work. If I plug 10, 0 in, do I get true statements? 0, 2 times 10 is 20, minus 9 is 11. Is 0 less than 11? Yup. 4 times 10 is 40, plus 3 times 0 is 0. 40 plus 0 is 40. Is 40 greater than 6? Yup. So I would argue this is a true statement. This is a true graph. All right, so I'm going to take my x to the fourth plus 4x cubed, and we're going to go to Desmos calculator. X to the fourth plus 4x cubed plus x squared minus 6x. Plus x squared minus 6x. And when they ask for the zeros, what they're asking for, where does it cross the x-axis? -3, -2, 0, and 1. So your answers are going to be -3, -2, 0, and 1. We're just typing that into the Desmos calculator. Your zeros are always where your, in this case, function crosses the x-axis. Those are your zeros.